This question is about a glucose-oxygen fuel cell. When the cell operates, the glucose molecules react with water at the negative electrode to form carbon dioxide and hydrogen ions. Oxygen gas reacts with hydrogen ions to form water at the positive electrode. Deduce the half equation for the reaction at the negative electrode. So it's telling us that glucose goes to carbon dioxide. It's telling us about water and hydrogen. I'm not going to worry about those because I know that I will add those when balancing my half equation. So it's telling me that glucose goes to carbon dioxide, six carbons in glucose, so 6 carbon dioxides. Then I'm going to balance the oxygens. So there are 12 oxygens on the right and only 6 on the left. So I'm going to add 6 waters, and that sort of ticks off that it reacted with water. Now I'm going to add up the hydrogens. There are 12, add 12, 24 hydrogens on the left. So I'm going to add 24 H pluses to the right, which means I'm going to add 24 electrons. Then it says oxygen reacts with hydrogen ions to form water at the positive electrode. So again, I'm not going to worry about the hydrogen ions, they'll get added in a second. So I need to put a 2 in front of the water because there's 2 oxygens, which means I'll need 4 hydrogen ions to balance the hydrogens and 4 electrons to balance the charge. Then it wants us to give an overall equation that occurs in the glucose-oxygen fuel cell. So it's kind of expecting us to multiply this bottom one by 6 to make the electrons match. You may well actually know this equation or work it out a different way, because a fuel cell is the reaction where the fuel is burnt in excess oxygen to make carbon dioxide and water. So you may want to just do it as a normal combustion equation rather than multiplying and then cancelling out all the waters and hydrogen ions, because what you're going to find is that when you multiply by 6, all the hydrogen ions will cancel as well as all the electrons, and you will end up cancelling some of the waters as well. Whereas if you do it this way, by just balancing it like a normal combustion, then you will get the same equation, just a different way. The negative electrode is made of carbon and the positive is made of platinum. Give the conventional representation for the glucose-oxygen fuel cell. This is a tricky one for a conventional representation. Put my salt bridge in the middle. I'm going to my negative electrode on the left. So I've got my carbon as my electrode. And then my negative electrode, if we look, is where the glucose is oxidized to carbon dioxide in acidic conditions. So glucose is a solution. It tells me that we've got glucose molecules react with water, so they'll be in solution. So again, a bit tricky because you have to make some leaps. Carbon is a solid. We've got our glucose solution, AQ. And then it's turning to carbon dioxide, which is a gas. And that carbon dioxide is acidified. So actually I need to put that acid in. And acid is H+, so that's in the same state symbol, so we'll just put a line, and then the carbon dioxide, so acidified carbon dioxide. And then on our positive half cell, oxygen is turning to water, but the oxygen is acidified, and oxygen is a gas, and the acid is aqueous. And then we've got turning to water, which is a liquid. Now, they will allow you to put a line or a comma because aqueous and liquid, they will consider those as the same phase. And then a line because we've got the platinum solid at the end. So it's quite a tricky conventional representation. State what must be done to maintain the EMF of a fuel cell. We must add reactants constantly so that the concentration of our reactants remains constant.